Seeraj's online math classes. Today we're going to be looking at algebra. So we're going to actually look at a quadratic now. The next question is to factorize 3x squared plus x minus 4. Now there's several different ways you can do this, and it all depends on what works for you. So the method we recommend, which is much simpler to do, is what they call the FOIL method. And what we do when we use the FOIL method, instead of expanding, FOIL applied to binomial expressions, finding the product of two binomial expressions. When we use it to factorize, what we actually will be doing is move this process, and we'll actually try to find the statement that will give us 4 terms in this particular expression, so that way we can use grouping and then be able to get both of the binomial expressions. So first, what we do once we can remember the general quadratic form, we'll be able to figure out what is our A, B, and C, and we know what A, B, and C represent, right? A is our coefficients of x squared. So here, A is 3. B is the coefficient of x. And in this particular statement, we have simply positive x, which tells us that B is positive 1. Now the signs are very important because, again, directed numbers, like I said, is a pivotal role in everything algebra. So one of the things you need to also pay very close attention to when you identify A, B, and C would be the signs in front of your numerical values. So that's why here, our coefficient is positive, A is 3. Our coefficient here is positive, B is 1. And our constant of minus 4 is negative, pretty obvious, negative 4. So we're going to write minus 4. What do we do from there? So usually, there tends to be a little confusion where you move once you get your A, B, and C values. And all you have to remember is this. When I want to figure out what pair of factors I'm going to use, I need to know what I must multiply by and what I must be finding the sum of. So, first of all, let's find the product AC. AC means we're going to find the product of 3 and minus 4. This gives me minus 12. So you see why direct numbers are so important in algebra? Now, why did I find AC? Well, the pair of factors I'm going to be using in this particular problem must be able to give me a product of AC. So I don't know what those two factors are. I have to multiply two factors to give me a product of minus 12. How am I going to get these two factors? Before I even think about the pairs of factors, I need to know that the same two factors that I'm using here, I find the sum of these two factors, that sum must be equal to B, which is positive 1. Now, you might look at it and you might say, okay, some of you who never really fully understood the concept, you might think, okay, you tell me to do X, Y, Z, but what am I essentially doing? When you have factorization by grouping, you usually have 4 terms. And here, we only have 3. So what we're going to be doing here is figuring out which pair of factors we can use. So we can take this middle term and break it up into a sum of 2 algebraic terms in X, which will give us the expression we want to use the factorization. So what we're doing from here now is going to consider pairs of factors of pairs of factors which give us minus 12. So the pairs of factors that we can consider. So yeah, one that jumps out is 3 and minus 4. Alright? So for those of you who probably feel a little unsure of this whole process of choosing pairs of factors, here's what you do. You can start off by looking at every single possible pair of factors, right? So I'm just going to look at positive squares. So 1 by 12, 2 by 6, and 3 by 4. Alright? And obviously you can switch the order because we know multiplication is commutative. So that's the reason I'm not too bothered about writing them in reverse orders. However, I need to bear in mind that the pair of factors I'm using must give me a numerical value of 12 when I find the product, but also a numerical value of 1 when I find the sum of the numbers. And obviously we can't use 1 by 12. Alright? We can't use 1 by 12 because while that product will give us a 12, yes, it won't give us a sum of 1. Because if I add 1 and 12, I'll get 13. Or if I subtract 1 from 12, I will get 11. And if I did the other way around, subtracting 12 from 1, I'll get minus 11. So either way, it rules out this first pair. What about 2 by 6? Do you think 2 by 6 is going to give us what we want? Yes, 2 by 6 could give us 12, it's true. But if I look here now, 2 plus 6 is going to give me 8. 2 minus 6 is going to give me minus 4. And 6 minus 2 is just going to give me 4. So this means I can't use this pair either. So it comes right back to the pair that has been staring us in the eyes. 3 by 4. Alright? So I'm just going to write in 3 by 4 first. Because I know that I can get a product of 12 if I multiply 3 by 4. But here's what I need to look at carefully now. I need to consider what signs I'm going to use because I have a negative product. Alright? But my sum is positive. So let's write in our pair of factors here. So 3 plus 4. If I found the sum of 3 and 4, I get 7, which is not what I want. I want a sum of 1. When I come back to my product, what do we know about finding product of directed numbers? We know that if at least one of these numbers here is negative, so if either 3 or 4 is negative, we'll get a negative result. Alright? But which one would we use as a negative? If we look here, they have 3 by minus 4. If I do 3 by minus 4, yes, I get minus 12. However, if I did 3 plus minus 4, this would become negative because 3 minus 4 would give me minus 1. That is how I know that the 3 actually has to be negative instead. So negative 3 times 4 is going to give me negative 12. And then I have here negative 3 plus 4 is going to give me positive 1. So these are the pairs of factors I'm using, right? This pair of factors, that's a pair I'm going to use. And what I'll do now, like I said, the process is reversing that for the method. So what we're doing with the positive x is going to write positive x as the sum of minus 3x and 4x. In our next line, we will write 3x squared. This remains the same. The positive x, like I said, we're bringing it up into minus 3x plus 4x minus 4. So for those of you who know about the process, but you always wonder, wait, how come, why, what? That's what you just did. You took this positive x, you changed it out for the sum of two algebraic terms in x, which will give you back that same sum as positive x. Next thing is, because we're going to be using grouping, that's the reason why we have to break up that single middle term into the sum of these two terms. From here, no, you are not going to find the sum of these. You're going to do factorization by grouping. So you're going to be looking at 3x squared minus 3x, positive 4x minus 4. You're looking at them pairwise, and luckily for us, this was already sort of paired off nicely. We can easily identify common factors, can't you? Here we can tell we have coefficients of 3. We have two terms, one in x squared and one in x. So if I wanted, I could factor out 3x easily from these two terms. Now 3x by something is going to give me back 3x squared. If I multiply 3x by x, I'll get back 3x squared. Now what am I going to multiply 3x by so that I get minus 3x? And the answer here is minus 1. Because if I multiply 3x by 1, I'll get the 3x. However, this is negative, so that's why I multiply 3x by negative 1. Let's move along. I'm going to look at this pair of terms now. We have positive 4x minus 4. If I wanted, I could factor out positive 4. Okay? If I wanted, I could factor negative 4. All of these are quite plausible, but which one is the right one? Well, one of the little tricks that I tell everybody about is this. When I want to completely factorize a quadratic expression, or any expression as the case may be where grouping is being used, I know I have to get two binomial expressions, which means that this bracket, whatever is inside here, I basically need that to be there as well. Because for complete factorization, I need to make sure I have another common factor involved in my expression. So here I have x minus 1, and like I said, because I know I want this bracket to look exactly like this one, I'm going to just write that in there. Alright, and now we're going to see what we factor out so we get this back. Okay, so if I factor out positive 4, and the reason why we have to write that plus 4 is because we are factorizing what? We're factorizing by taking out a positive 4. So from here, I can just double check to make sure that I have the correct signs, that it is correct factor, that I am in fact on the right path. So positive 4 by positive x gives me positive 4x. Positive 4 by minus 1 gives me negative 4. So you see that we get it. We get exactly what we wanted. If you wanted to do it the way where you just choose a factor and then you found both in the brackets, you'd still get the same answer. But you would have to remember that you have to still double check the sign of the factor so that these two brackets are in fact the same. Once you have this statement, once your binomial expressions are exactly alike, all you need to do now is factorize by factoring out this common factor of x minus 1. So, some people have been learning the process of factorization of quadratics by saying, okay, once you get here, you just write this and then you write that in a bracket. Understanding what you are doing helps you further reinforce the things you've been learning, and that way whenever you have any problem with math, you are able to apply that understanding and that knowledge to do any single troublesome thing that you know you probably would have looked at before and thought, hey, I don't know how to do this. So understand what you're doing, and if you understand what you're doing, you'll never meet a quadratic that you can't factorize. So from here, all I'm going to do is factor out my x minus 1. So that's my common factor. That's the reason why I'm factoring it out first. Alright? And then, what did I factor out x minus 1 from? Well, this was an entire term, 3x times x minus 1. So if I want to get back this whole term, I have to multiply x minus 1 by 3x, and that is why we have 3x here. Now, again, this is a whole term here. That is 4 times x minus 1. So what I'll do is factor out the x minus 1 like we said here. But what do I need to multiply this by back so that I get this 2? Just 4. Just 4. Right? Positive 4. And that's how we completely factorize a quadratic expression. Now this is with 2 marks. Right? So you basically will get your mark for being able to do your factorization where you can identify these two binomial expressions which make up the factorized form. Okay? And what I want to also point out, most times when I grade papers with algebra, if you were on the right track, say for instance you have factored out the correct things up here, you didn't get to here, you still get a mark because it showed that you understood the concept of doing the factorization process. Now, some people were so good at doing the factorization questions. If it was so easy, they went on further to go and solve for x, which was not required. Because if you look at this, just remember that elementary little principle you learned about algebra from the very beginning. Whenever you have expressions, there is no equal sign. And if you don't have an equal sign, you can't equate anything, and you can't solve for any variable. Alright? This is an expression. Do not solve your expressions. Don't solve for variables and expressions. Okay? It is an expression. If they had put this was equal to 0, then you proceed. Alright? Remember again, read your instructions carefully so you save yourself the time, the stress, and the worry. Now, I know some people, they know how to do the factorization on the scientific calculator. Yay, that's all good. But what I really want to point out is that if you're using that method to help you hack the factorization process, I really want to urge you to remember you're not solving for x, and the calculator, what it does is actually give you the result as a root or the value of your variable x or y, whatever the case may be. Okay? So if you wanted to use the calculator shortcut, which I strongly suggest you don't go that route all the time. If you wanted to do that shortcut, you have to remember that you need to write them back as a binomial expression. Okay? So if you, for instance, would have gotten x is equal to positive 1 and x is equal to minus 4/3, to write the binomial expressions that make up the factors, you have to remember x equal to 1 means x minus 1 was the factor, and 3x plus 4 is the factor where you had x is equal to minus 4/3. Okay? So you can erase the answer on the calculator.